So let's start. In our last class, we came across the concept of 4-point FFT and in general the concept of butterfly and the savings in computational load. Now today we want to see our 8-point FFT. If we study 8-point FFT, then our observation will be much more generalized. Okay, and we can obviously conclude something. So our 8-point FFT. Now we recall relation 25, relations 25 and 26. What was that relation? It was actually the segregation of even harmonics and odd harmonics. Just I want to show you these the equations. That is, so this is our relation 25. So our n-point FFT, DFT is decomposed into one even harmonics, x of 2p, p is an integer. According to relation 25, we are getting it. And relation 26, this is the odd harmonics, decomposition into odd harmonics. Okay, so we just want to recall these relations 25 and 26. Okay, so let's write it again. So it is x 2p equal to summation gk w n by 2 to the power pk. K is varying from 0 to n by 2 minus 1. This is from relation 25. That is the n by 2 point DFT of gk. And x2p plus 1. Okay, it is also n by 2 point DFT but of gk dash. So wn by 2 to the power pk. Okay, it is from 26. Now what we do, we split this relation 25, that thing, into again two n by 4 point sequences. That is n by 2 point DFT. Now we will just split into n by 4 point sequences. So splitting n by 2 point sequence of gk, okay, in relation 25 into 2 n by 4 point sequences. What it will be? Let's see this thing. It is x 2p, this one equal to summation gk wn by 2 to the power pk, and k is varying from, now here it is varying from 0 to n by 4 minus 1. That is n by 4 number of points, plus k is varying from n by 4 to n by 2 minus 1. So we are further segregating it. gk wn by 2 to the power pk. Then summation gk wn by 2 to the power pk, k varying from 0 to n by 4 minus 1, plus summation gk plus n by 4. Note that here we are just shifting it. K is varying from n by 4 to up to some term. So we write k plus n by 4. Then what will be the starting value of g? Here starting value of g is n by 4. Here also the starting value of g should be n by 4. So k should start from 0. 0 to n by 4 minus 1. Actually, the same result you can get if you put k minus n by 4 equal to some p, some integer, and that integer will vary. K minus n by 4 equal to some p, then change later after some manipulation, change p to k, you will get this expression. The method already told in some previous class when I discussed 4-point FFT. I am not repeating the same discussion. Directly from this step, I am writing that one with a conception, with an understanding that the starting value of here is gn by 4. Here also starting value of g is n by 4. The n value of g here is n by 2 minus 1. If you put the n value of k, you will also get that the n value of g will be same, that is n by 2 minus 1. So there is no change at all. Here also it will be wn by 2 p. So k will be replaced by k plus n by 4. So k plus n by 4. So that is there. So just we are doing it with some step jump, but conceptually it can be understood. Okay. Now our next step. Similarly, sorry. Now note that here Pn by 4 is a constant term. Our k is variable. We can take it outside. So Wn by 2, Pn by 4, then summation. Okay, Gk plus n by 4, Wn by 2, okay, to the power Pk. Okay, and k is varying from 0 to n by 4 minus 1 as usual. We are taking that term outside. Okay, so it is summation k equal to 0 to n by 4 minus 1 gk wn by 2 to the power pk plus. Now note that this is equal to actually minus 1 to the power p. Okay, I write it here since wn by 2 to the power p n by 4 equal to minus 1 to the power p. It is very easy to prove. Just put e to the power minus j 2 pi by capital N by 2 whole to the power p n by 4. Ultimately, it can be easily proved. The method I already told you probably in the last class. Okay, same thing. So k is varying from 0 to n by 4 minus 1. G k plus n by 4 w n to the n by 2 to the power pk. That one. Okay. So therefore we can write, therefore x 2p equal to, we are taking summation sign as common. Then we are writing gk plus minus 1 to the power p, okay, g k plus n by 4, then w n by 2 to the power pk. This is relation 35. This is our relation 35. Okay, so that is the general expression of H2P. Now again we want to take X2P, we want to resolve X2P into even order and odd order. Okay, then see what happens. So I write it in the next page. Page number 2. Now X2P is split into even and odd harmonics. For even harmonics, P equal to 2R. Okay. So P is taking integer value. We are considering only the even values of P. For R equal to 0, 1, 2 up to n by 4 minus 1. And for odd harmonics, P equal to 2R plus 1. For R equal to 0, 1, 2 up to n by 4 minus 1. Okay. Now what we do? For even harmonics, we substitute P equal to 2R. So in the previous expression, we write P equal to 2R, x2P. So 2 into 2R, so 4R equal to summation K is varying from 0 to n by 4 minus 1 Gk plus, now see our previous thing, just this is, you put P equal to 2R, so minus 1 square plus 1 it is always. Here also put P equal to 2R in relation 35. Okay. So it is G K plus G K plus n by 4 W n by 2 to the power 2R K. Put P equal to 2R. Okay. So P equal to 2R in 35, relation 35. Okay. For R equal to 0, 1, 2 up to n by 4 minus 1. Substituting. Right? Then we can write it. E K is varying from 0 to n by 4 minus 1. Okay. Gk plus Gk plus n by 4. W. Now we divide the base and the power by 2. So Wn by 4 and power will be Rk. So you know it is using relation P3. Okay. Using relation P3, we already got it. N by 4, then that 2 will not come here. Okay. Now let you put Hk equal to Gk plus Gk plus n by 4 for k equal to 0, 1, 2 up to n by 4 minus 1. Then what happens? X4R equal to summation Hk Wn by 4 to the power Rk. Here k is varying from 0 to n by 4 minus 1. That expression. Okay. So this is what? Your base is n by 4 and the number of points are also n by 4. So effectively this is, okay, I better write you it relation 36. Relation 36. So this is an n by 4 point DFT of sequence HK, where K is 0, 1, 2, okay, up to n by 4 minus 1. So this is the even harmonics. For even harmonics we are getting. For odd harmonics, what we do? just for odd harmonics, just will put equal to 2r plus 1. So x2p would be equal to 2r plus 1. So it will be for odd harmonics. X, then it will be 2p plus 1. Put 2 into this plus 1. Okay. So it will be x 4r plus 2. Okay. So in relation 35. In relation 35 means that one you put x 2r plus 1.
So 4r plus 3 হবে না?
4r plus 2 equal to summation gk. Now you see it is minus 1 to the power p. P is odd, 2r plus 1. So it will remain minus 1, negative. Here it became positive, but here it becomes negative. So g k plus n by 4. Okay. W n by 2 to the power pk. Put in place of p, you put 2r plus 1. In place of p, it is 2r plus 1. Okay. So you can write p equal to 2r plus 1 in 35 for r equal to 0, 1 to up to n by 4 minus 1. My friend. Oh. So this is n by 4 minus 1, gk minus gk plus n by 4. Now we just take just 1 minute. It will be w n by 2 to the power k, then w n by 2 to the power 2rk. Okay, this is the step. Now what we will do, we can also multiply it with 2, then wn to the power 2k to be. So I write it in the next page, page number 3. Equal to w, you see here, you multiply both the thing by 2. So it will be 2k and wn. So you can write wn to the power 2k and you divide this by 2. So it will be wn by 4 to the power rk. So it is w n by 4 to the power rk. So that is our thing. So let hk dash equal to that one, wn to the power 2k. Just this part we are adding it hk. Or we also can write it gk minus k plus n by 4 to the power wn by 2 to the power k. Just I am writing all the terms. Okay. For k equal to 0, 1, 2 up to n by 4 minus 1. So then what it will be? It will be x 4r plus 2 equal to n by 4 minus 1. So we write it hk dash, then w n by 4 to the power rk for r equal to 0, 1, 2 up to n by 4 minus 1. So this is our relation 37. Relation 37. Again you see this is an n by 4 point DFT of sequence HK dash. K is varying from 0 to up to n by 4 minus 1. So here is base is n by 4 and number of points also is n by 4. So our conclusion is that thus the n by 2 point DFT, okay, as represented in relation 25 may be split into two n by 4 point DFTs as represented in relation 36 and 37. This one. Okay. So that is for which was 2p. That is for x2p. That is splitting this for x2p only. Now from relation 26 also we should split into an even term and odd term, odd harmonics. Okay, we'll do it now. Similarly, splitting n by 2 point sequence of gk dash in relation 26 into 2 n by 4 point sequences will be what? Is x, we are writing it x2p plus 1. X2p plus 1 equal to pk dash wn by 2 to the power pk, but k is not varying from 0 to n by 2 minus 1, rather it's varying from 0 to n by 4 minus 1 plus, now k is varying from n by 4, the next point, to rest of the term, n by 2 minus 1. So total n by 2 number of points here also. Yeah, equal to first part is same, a change in the second part. Here it will write gk plus n by 4. The starting value is g dash n by 4, so it will be k should start from 0 to n by 4 minus 1. W n by 2 p, k will be replaced by k plus n by 4. Already discussed in the previous class also. This is we are getting that. Okay. Now we will just break up into two part series here. That I'll do it in the next page. Page number 4. Okay. So it's equal to, first part is same. Next is second part. GK dash A plus N by 4. Now we are resolving it. One is Wn by 2 to the power Pk. Another is Wn by 2 to the power Pn by 4. Just I want to show you again. Say here. Wn by 2 to the power Pk into Wn by 2 to the power Pn by 4. Pn by 4. Okay, so this is that term. Next, equal to, again first part remains same, and the second part W n by 2 to the power Pk W. Okay. So I write it. Actually, this is the constant part. So better I should take it outside. Okay. So I just want to cross out Pkwn by 2 to the power Pk. Here there is no K, this part, so taking it out. Wn by 2 to the power Pn by 4 summation G dash K plus N by 4 Wn by 2 to the power Pk. A varying from 0 to N by 4 minus 1. So to get to the next step, this is minus 1 to the power P summation again W n by 2 to the power Pk. Since W n by 2 to the power Pn by 4 equal to minus 1 to the power P can easily be proved. Therefore, X 2P plus 1 left hand side equal to, I take this as common, K varying from 0 to N by 4 minus 1. Just 1 minute, it will be GK dash. Everywhere it is GK dash. I see it in the next step. So this is also GK dash, GK dash. Okay. So GK dash plus minus 1 to the power P. Oh, X 2P plus 1 equal to GK dash plus minus 1 to the power p g dash k plus n by 4 wn by 2 to the power pq. Okay, that is a relation. So that is this particular thing. I write it in relation 35a. Why? Because actually I forgot to uh, my next, there was a mistake here in numbering system. I just forgot to give a number here. All other numbers are coming as usual. So I write it this way. Okay. Doesn't matter. Now x 2p plus 1 is split into even and odd harmonics. For even harmonics, p equal to 2r, just like the previous case. For r equal to 0, 1, 2 up to n by 4 minus 1. For odd harmonics, p equal to 2r plus 1. For r equal to 0, 1, 2 up to n by 4 minus 1. Now what happens to the even harmonics? I'll write it in the next page, page number 5. Okay. So for even harmonics, we write x 2p plus 1, we put p equal to 2r, so 4r plus 1. X, this is x 2p plus 1, put p equal to 2r, so it will be x 4r plus 1. X 4r plus 1 equal to k equal to 0 to n by 4 minus 1. K dash. Now k equal to 2r, p equal to 2r, it will be plus, then it is plus, the sign becomes plus here. Yeah. P dash k plus n by 4 to the power p now will be replaced by 2rk. Okay, for p equal to 2r in 35a. Okay, for r equal to 0, 1, 2 up to n by 4 minus 1. Right. Now we put let Lk is equal to that one, Gk dash plus G k plus n by 4 dash, the whole thing, for k equal to 0, 1, 2 up to n by 4 minus 1. Then x 4 r plus 1 is equal to, this is Lk, Lk Wn by, now we just divide it by 2, so it will be Wn by 4 to the power Rk for r equal to 0, 1, 2 up to n by 4 minus 1. This is our relation 38. This is, see, base is n by 4, number of points also is n by 4. So this is an n by 4 point DFT of sequence LK. K is 0, 1, 2 up to n by 4 minus 1. Okay. Our next one is for odd harmonics, even harmonics, for odd harmonics. What happens here? See, this is our x to p plus 1. You put p equal to 2r plus 1. So 2r plus 1. So it is 4r plus 3 actually for odd harmonics. x4r plus 3 equal to
So we cannot hear you.
Sir, you are muted.
Sir, your mic is not connected. Sir, you are not audible.
On phone call.
এখন ফোন কর।
okay. So am I audible now?
Yes, sir.
Yes, sir.
শোনা যাচ্ছে?
হ্যাঁ স্যার এখন শোনা যাচ্ছে।
ঠিক আছে, let's start. So it is now Wn by 2, 2rk, Wn by 2 to the power k. Okay. Or we can write it x 4r plus 3 equal to just the manipulation is as usual. It is Wn to the power 2k. This part I'm writing first. Then Wn by 4 to the power rk for okay p equal to 2r plus 1. Okay. And r equal to 0, 1, 2 up to n by 4 minus 1 as usual. Okay. Now we write this whole thing as LK dash. I write it in the next page. Okay, I write it in the next page. So it is page number 6. Okay, so you can write it or x 4r plus 3 equal to summation k is varying from 0 to n by 4 minus 1 LK dash W n by 4 to the power RK for R equal to 0, 1, 2 up to n by 4 minus 1. Okay. So where this is our relation 39. Our relation 38 was written, now this is 39. Where, so this is another n by 4 point EFT, where our LK dash equal to GK dash minus GK plus n by 4 dash Wn to the power 2k, or GK dash minus GK plus n by 4 Wn by 2 to the power k for k equal to 0, 1, 2 up to n by 4 minus 1. Clear? So our even harmonic things are resolved into even harmonics and odd harmonics. Next day, I think next day we'll be able to complete the 8-point FFT. Our basic equations are ready. So next thing is, the next day we will put n equal to 8. Next day means tomorrow, I think. Tomorrow. No, not tomorrow. It will be Saturday then. Okay. তাই তো নাকি? Saturday to class.
Yes, sir.
Saturday. So we'll put this thing. And we'll complete the concept of 8-point FFT.
Sir,
বলো।
earlier you took n as a power of 2. Now you are taking as n as a power of 4. You were saying that after, I mean, in the next class you will take n as a power of 8. So how far?
No, here n is always power of 2, not a power of 4. In our entire discussion, n is always a power of 2. So if n is power of 2, then 2 to the power something, then n point DFT will be resolved into 2 n by 2 point DFT, and each of the 2 n by 2 point DFT will be resolved into again 2 n by 4 point DFT. Each of these n by 4 point DFT will be resolved into n by 8 point DFT. It
And
will
likewise.
go likewise. So ultimately, we will find out the general algorithm or the general steps. Okay, just I want to remind you, the general algorithm is already presented before. What is that? I want to show you again. Just wait 1 minute. Somewhere it's there. No, not here. Yes, this one. See, this is n point, n number of samples. Through the butterfly structure, we are getting 1 n by 2 point DFT.
Yes.
That way. So from these n point samples, we are constructing GK. From GK, we are getting 1 n by 2 point DFT. And again, from these samples, we are constructing GK dash. Then we are getting n by 2 point DFT. So from 1 n point samples, you are getting 2 n by 2 point DFT. Similarly, from again these n by 2 point samples, you will construct 2 n by 4 point DFT here and another 2 n by 4 point DFTs here. So same thing will be repeated here and here, recursive structure. It will go
Okay,
on
sir.
this way.
Okay, sir.
So up to this today.
Thank you, sir.